Okay, good morning. I hope that you enjoyed your holidays and ready for the new lessons. So we go to chapter 4 today, and that is more or less the application of the notion of derivative that we have learned during chapter 3. Um, so we start today with talking about a type of functions which are important for the next lesson that we will study tomorrow, okay? And that's the notion of increasing and decreasing functions. Of course, I think the name is already telling you what is the meaning of this, but let us try to understand that. So, understanding it graphically is very simple. So, if you have a function, so if you have this coordinate system, so if you have a function like this, we say that the function is increasing. And increasing means always by convention, when I go to the right, the height of the graph goes higher and higher. This is the meaning of increasing function. Of course, it is clear if I start moving to the left, the height will go down. So by convention, when I say a function is increasing, it means that when I go to the right, the height of the graph of the function actually increases. That's the meaning of course, this is a little bit vague. I have to make it more precise. But that's the meaning of increasing function. But of course, you know that might be this is not the case. For example, might be at some point the function starts returning back, yes? So I cannot say that this function is increasing, or I cannot say this function is decreasing, because this function is increasing in some part and it's decreasing in another part. So this means that when I want to talk about increasing and decreasing functions, I have to specify them on a given interval. So for example, I can say that if this is a, and for example, up to here, it's b, so I can say that my function is increasing on this interval. So it goes high, upper and upper, up to this point. And then from this point on, after that, it will return back. So this after b, the function is decreasing, but on this interval, the function is increasing. That's the meaning of increasing or decreasing functions. But if I want to define them rigorously, how can I define them? I would say that, okay, I have an interval, so I have this interval, say, between a and b, and I have a function f. Okay, can you tell me how can I define it mathematically, this idea? Because using the graph, it is extremely simple to understand where the function is increasing or where the function is decreasing. Okay, but if I want to have this idea in mathematical way, how should I define that? For example, I give you this interval, a and b, and then I give you a piece of graph, and I say that this function, of course, this function is increasing on this interval. Everyone hopefully agrees. What is the meaning of this mathematically? If you want to write this in mathematical way, how do you define that? Yes? No, this is a consequence of that. Okay, what's the definition is what? This definition is exactly what I mean, yes? It means that if you consider 2 points, let us say x1 and x2 on this interval, and if x1 is less than x2, what can I say about f of x1 and f of x2 if the function is increasing? What happens? F of x1 is this much, yes, and f of x2 is this much. Yes, if the function is increasing, it means that if a number x1 in that interval is a smaller from another number on that interval, the corresponding value of the function at that point is also shorter than the corresponding value of that one. So this means that if x1 is less than x2, then f of x1 is also less than f of x2. Okay, so this is the definition when we say that a function is increasing on this interval. It means that if x1 is between a and b, x2 is also between a and b, and if x1 is less than x2, then f of x1 is less than f of x2. Is that understandable? This is exactly the meaning, yes? Is that clear? So a function is increasing if the value of the function at a lower number is smaller than the value of the function at a higher number. That's the meaning of increasing, yes? Of course, there is another, because different books use different terminologies. When I see your book, instead of saying increasing, they say strictly increasing. Strictly increasing. So they use the word strictly increasing for this situation. And I think this is correct. This is good, I will tell you. And then in your book, when they talk about increasing, they write the same thing, and then they write f of x1 is less than or equal to f of x2. So in your book, we have this distinction. When we say strictly increasing, this is the definition. When I say just increasing, this is the definition. Okay, can you tell me what is the difference between these two cases graphically? So for example, is this function increasing or not? Is this function, let me consider a straight line, a horizontal straight line. If I say that this function is increasing or strictly increasing, this is the difference, yes?
Yeah, this would be increasing, but it wouldn't be strictly.
It's not strictly increasing, yes? Because strictly increasing means that when x1 is strictly smaller than x2, this will imply that f of x1 is also strictly smaller than f of x2. But this does not happen here, yes? For example, if I say that this is 5, if I say this is 1, if I say this is 3, if I ask, and this is the graph of the function f of x, say, if I say that 1 is less than 3, everyone agrees, of course, but then if I calculate f of 1, the answer is 5. If I calculate f of 3, the answer is again 5. So even though 1 is less than 3, but f of 1 is not less than f of 3 because they are equal. So this function is not strictly increasing, but it is increasing. Yes, of course this function is constant, but every constant function is also increasing and decreasing. So this is the scenario. So what I want to say, it's better to understand this scenario from this perspective. If I have a graph like this, or if I have a graph like this, there is a difference between them. Yes, this function is strictly increasing, and this function is not strictly increasing, it is increasing, but not strictly increasing. Yes, is the difference clear? Yes?
If it was like this, then the y coordinates would be same for x1 and x2 still.
No, but in that case, it is not increasing, it is not decreasing. At some part, it is increasing, at some part, it is decreasing. We will come back to that, yes? But this graph is increasing, but not strictly increasing. But this graph is strictly increasing. So it means that when I go to the right, the height of the graph is always growing. But here, when I go to the right, at some point, the height of the graph is growing, but at some point it remains constant, then again it grows, yes? So this is the difference between strictly increasing or increasing. Well, can I say this is also increasing? Can I say this graph is also increasing? Yes, because every increasing graph, it's automatically, Every strictly increasing graph is automatically increasing as well, yes, but not the other way around. Okay, I don't want to, because this topic is not that hard, I don't want to confuse you, but I hope that you understand the difference between increasing and strictly increasing. Yes? Okay, the same thing, I don't want to repeat these things. The same thing we can talk about decreasing functions. Let us practice, okay? You can talk to me so that you can have this practice. Okay, so for a decreasing function, hopefully you understand what I should do. For example, this is a graph that is decreasing on this interval from a to b. The function is going down on this interval. And assume that this function is f of x. Okay, again, tell me, how can I define this mathematically now? What is graphically it is really clear. When you go to the right, the height of the graph goes down. That's the meaning of decreasing, or strictly decreasing again. Okay, but can you define it for me mathematically? So I would say that my interval is from a to b, and then I choose two numbers x1 on that interval, x2 on that interval, okay? I want you to write something similar to this for me for this case. So what should I write now? Yes?
F of x1 is smaller than f of x2. Or
Oh, but first, what should I write here?
oh yeah, that x1 is smaller than x2.
x1 is strictly smaller than x2. It means that I choose two numbers in that interval. One of them I call x1, the other one I call x2. I respect that x1, for example, is smaller than x2. Then this would imply that if the function is strictly decreasing, what does this imply then? Yes?
That f of x1 is greater.
Greater than, yes, exactly. So f of x1 is greater than f of x2. So this is the meaning of increasing or decreasing functions, yes? And if this is strictly decreasing, strictly decreasing. But if I want to write decreasing only, of course you understand probably what to do, then this would then imply that f of x1 is greater than or equal to f of x2. So this is decreasing. So if I want to draw a graph of decreasing function which is not strictly decreasing, you already probably know what to do. For example, you can come with a curve like this and become flat at some point, and then, for example, go down like this. So this function is decreasing, but not strictly decreasing, because at some point, on some interval, it becomes flat. So this is strictly, this is decreasing, but not strictly decreasing. Okay? But again, as you already could predict it yourself, probably you see that most functions are not like this. For example, the famous graph that we have here, y equals to x squared. If I say this function is increasing, that is not correct. If I say that this function is decreasing, that is not correct either. Yes? Because this function is decreasing on this interval from 0 to the left. So if I confine myself to the left-hand side, then my graph is going down constantly. But at this point, it starts going up. So this function is decreasing on the interval. We say that this function is decreasing on the interval x greater than or equal to 0. It's decreasing when this happens. And I say that this is increasing when this happens. Of course, in this case, I can also add this adverb strictly, yes? And I can also add this strictly. And you see that I have put 0 here and there, because you cannot say that the function is increasing or decreasing at a single point. Yes, it is nonsense to say my function is decreasing or increasing at one single point. Because if you want to understand if the function is increasing or decreasing, you have to pick up 2 arbitrary points in that interval that satisfies this to see which one of this one or that one is happening. Yes? So when I say that my function is decreasing on this interval or strictly decreasing on this interval, it means that if I pick 2 points from this interval so that one of them is smaller than the other one, then f of the first one is greater than the first f of the second. So this is why it doesn't matter, and of course I mean the correct way is to put 0 here and there. Is that understandable? Yes, because so if you want to understand this, it means that it doesn't matter any 2 points that I choose on this interval. It is also possible to choose 0, so that one number is smaller than 0. Definitely f of that number is greater than f of 0. Yes? And the same thing for the other. Okay, but let us give some examples to understand this better. Okay, for example, can you give me, now let us do analytic work, forget about the graphs. Can you give me a function which is increasing? A simple function. F of x is equal to x. Of course, I hope that you agree with me that you don't need to be very smart to understand this is increasing function. It's a strictly increasing function. Why? Because if I choose x1 and x2 so that x1 is less than x2, hopefully you agree with me, f of x1 is also strictly smaller than f of x2, no matter which x1 and x2 I have chosen. Is that clear? Because this function, if I increase, let me, by the way, make it very simple for you. Whenever you increase x, f also increases, the function is increasing. Whenever you increase x, but the function decreases, the function is decreasing. Yes, for example, this function is increasing. Why? Because when I increase x, the value of the function, which coincidentally is x itself, in this case, will also increase. Is that clear? Yes? Yes or no? But for example, this function, could you predict that this function is not having this property? Because here, if you increase x, there is no guarantee that f of x also increases. Why? It's a little bit counterintuitive, but you have to be careful, yes? You might think that, okay, it is clear that when I increase x, f of x will also increase, but that is not correct, yes? Why is that? Yes? Yeah. Because if I choose, for example, -4, and if I choose -3, which one is greater than the other one? Of course, -4 is less than -3. Yes? But if I calculate f of -4, it becomes 16. If I calculate f of -3, it becomes 9. This is not correct. Yes? So this is for this function, we cannot say this function is increasing. We cannot say this function is decreasing. Yes? There is no guarantee by increasing the value of x. If there is a guarantee that by increasing x, f also increases, the function is increasing. If there is a guarantee that by increasing x, f decreases, the function is decreasing. But in any other cases, there is no guarantee, we cannot say anything. For example, what about this one? I write a function here, g of x, x to the power of 3 plus x plus 1. What do you think? We don't have the graph in our hand now, but what do you think about this function? Do you think this function is increasing or decreasing, or it is a subtle question to answer at this level right now? Yes?
I think it's increasing.
Do you agree that this is increasing? Yes, because if I start increasing the value of x, the value of this function will also increase. Is that clear? Yes or no? But I mean that intuitively. Why? Because if x1 is less than x2, everyone hopefully agrees that x to power 3 is less than x2 to the power of 3. And then I add x. So then what does it mean? It means that x to the 1 to the plus x1 to the power of 3 plus x1 plus 1 is definitely less than x2 to the power of 3 plus x2 plus 1. So that's clear. What about this function? H of x equals to 1 over x to the power of 3. Yes?
It's decreasing.
Is there any guarantee to do that? So if, by increasing x, you might think that h will also, this will decrease because I am making the denominator bigger, but the numerator is fixed. But do you think this is increasing or decreasing? You have to be careful. Like what I mean, I just want you to feel that this question is not that easy to answer all the time with certainty, unless we have a systematic way to understand it. Okay. For example, even in that case, what happens if I change this positive sign to negative sign? So if I write x to the power of 3 minus x plus 1, for example, when I write s of x, and I ask you the same question, is this function increasing or decreasing? Yes, it is not that easy to answer, because if you increase x, of course this increases, but simultaneously this also becomes bigger, and this is the difference. We have to know which one will dominate to be able to answer that question. So I want you to get this feeling by making the function more complicated, even though conceptually this question is understandable and easy, but practically it is not that easy to answer it if you just want to use this crude definition. So you have to be able to cook up or have a recipe, a systematic recipe to be able to answer this question. Yes.
Does a function always have to increase or decrease to be increasing or decreasing? Like every time you increase x?
Yes, of course you can. Yes, that is the meaning of increasing or decreasing, but you can say that my function is increasing on this interval and it is decreasing on another interval. And most of the functions are like that. Yes, but I just want you to understand that answering this question is not that easy if the form of the function becomes complicated. Is that clear? So this is why we need a more systematic way. Working with inequalities becomes extremely hard if the function is actually complicated. So we want to see if there is a systematic way that we can answer this question, that if the function is increasing or decreasing. Yes? Is that clear? Okay, now let us understand it so let us connect the idea of derivative to this concept. Okay, so how can I use the notion of derivative to answer this question more systematically? Okay, so what is that? So this lesson is more intuitive, because if I want to prove things mathematically or rigorously, we need some more advanced theorems in mathematical analysis, which we don't have right now. So you just need to understand it. But it is extremely important to understand the idea. Yes? So let us consider a function, for example, like this. Yes, it continues forever from this side and continues forever like this from that side. And then, of course, can I say this function is increasing? The answer is no. Can I say that the function is decreasing? The answer is no, because it is increasing on one part and it is decreasing on the other part. Yes? So, for example, let us consider this one to be a. Okay, so you see that the function is increasing on the left-hand side of point A. So what is the common property of all the points on the curve? Yes, so for example, if I consider this one, or if I consider this point, if I consider this point, these are different points on this part of the graph where the function is increasing. But all of them have something in common. I just want you to think about derivative, how derivative comes in here. Yes?
The k value at all these specific points are positive.
Positive, yes, because intuitively, if I draw a tangent line here, yes, the tangent line here is inclined in this direction. The tangent line here is inclined here. The tangent line is inclined in this way. Of course, these slopes are all different, but what matters is that the slope of all these lines are positive. Yes? So it means that if f prime of x is positive, this means that I am on that part of the graph where the function is strictly increasing. Yes? But now look, when I go to the decreasing part, and if I draw these tangent lines, of course these slopes are again different. All of them are different. But all of them are now negative. Because the slope of these lines, you already know that the slope of this type of line is positive. The slope of this type of line is negative. The slope of this type of line is 0. And the slope of this one is not defined. Yeah, so this is important to know, okay? So you see that on the increasing part, the derivative is positive, and on the decreasing part, the derivative is negative. Yes? So for example, let us go back here. Look at this function again. You were able to predict correctly that the function g is strictly increasing. Okay, but this idea is very simple here. This idea tells you that whenever you want to see at which part the graph is increasing and at which part the graph is decreasing, the recipe is this. Take the derivative and you yourself solve this inequality. This will give you all the intervals on which the function is strictly increasing, and solve this inequality. This will give you all the intervals on which the graph is decreasing, strictly decreasing. Yes? The recipe is very clear. But there are many of these type of things that coming in this chapter, and there's none of them is in the formula sheet, so you need to have a good understanding, this intuitive picture in your head to be able to understand what is the idea, because memorizing them is not possible. There are many of them. Okay, so for example, that function that I told you, and you predicted before that this function is strictly increasing. Now, can you confirm it with this new recipe again? Why do you think this function is strictly increasing? Why? Instead of looking at inequalities and solving inequalities like that, the first step that I do is to take the derivative. When I take the derivative, I hope that you haven't forgotten what's the derivative. Yes? 3x squared plus 1. Okay, I want to know where the derivative is positive or where the derivative is negative. So what is your answer to that? Where the derivative is positive and where the derivative is negative? By where, I mean for which x's the derivative is positive and for which x's the derivative is negative. Yes, Hafsha?
We can first put the g prime
Mhm.
is greater than 0 and then solve for that and then less than
This is a systematic way of doing that, but can you predict what will happen if you do it for this particular case? It's always positive. Why is that? Because x, no matter what x is, x squared is non-negative. Yes? It cannot be less than 0. If you multiply it by 3, it is still non-negative, but when you add 1 to it, it becomes what? Positive. So this means that regardless of the value of x, the derivative is positive. So I would say that g prime is positive for all x. So this means that G, so this implies that G is strictly increasing. We can say for all value on all the whole real line, or I say that on R. So it means that it doesn't matter on which interval you're looking at this function is always increasing. Yes? But what about the other function? That is a little bit more problematic, but that is a third degree, so let us solve that one. So this g of s of x is x to the power of 3 minus x plus 1. Okay, we want to answer the question on which interval or intervals this function is increasing and on which interval or intervals this function is decreasing. Okay, so what should I do systematically? From this recipe that we learned here, the first thing comes to mind is to take the derivative. Okay, so we take the derivative here, we differentiate the function, so it becomes 3x squared minus 1. Of course, might be this is not a good starting example. It's a little bit hard. Hopefully you can understand that. Okay, so let us solve this together. So how should I understand that one now? For having the function to be, so for a function to be strictly increasing, I put the derivative greater than 0. Okay, so I have to solve this to see where the function is increasing. S prime of x is that function that I got there, so I need to solve this inequality. Yes? So how can I solve this inequality? This is why I'm saying that this might not be a good example at this point, but I think it's not that hard to understand. So 3x squared minus 1 is greater than 0. How can I solve that? Yes? First I move this one, but you have to be careful at some point, eventually. Okay, because I want to isolate x, then divide by 3. But this is the part you have to be careful. So you want to have x squared strictly greater than 1/3. So what should I do then? I mean, if you take square root, this is not the whole story, yes? I mean, coming from here to here is not wrong, but it's not complete, yes? You want to have x squared greater than 1/3. One possibility, of course, is to choose x greater than 1 over square root of 3. Because if you choose x greater than 1 over square root of 3, you already guarantee this to happen. But this is not the only case that you can guarantee this. Can you imagine another thing? Yes?
If x is negative, you can guarantee that x necessarily be greater than 1 over square root of 3.
No. Any negative number, you mean?
Well, I mean, if you know x squared is greater than 1/3, right? That doesn't necessarily mean that x is greater than 1 over square root of 3.
Okay, so at the end, if I want you to understand, I want to understand you, you need to tell me how to complete it.
Well, I will. Let's say that.
Now, let me give you a simple example. If I ask you to solve this, by the way, you should be able to solve this, even though for some reason in Swedish curriculum you don't study these kind of inequalities, but it doesn't mean that it's hard, you cannot understand them. If I ask you to solve this inequality, I am asking for finding all possible values for x so that x squared becomes greater than 4. Of course, this is true that if x is greater than 2, this already guarantees this is the case. That is true. But is this the whole story? That's what I'm asking. Because when I ask to solve, I don't mean to give me partial answers. When I ask solve an equality, I mean give all possible answers. Yes, sir?
Another possible answer for x squared is bigger than 4 is also x is smaller than negative 2.
Yes, everyone agrees. X smaller than -2 will also work. Yes? Because if x is less than -2, when I raise it to power 2, it becomes positive greater than 4. So if x is less than -2, then this also guarantees that x to power 2 is greater than 4. I want you to tell me, do you understand why this is correct? Yes? Okay, so what should I write here? Now tell me, what should I write? Do you agree if I write this and that, or what should I write?
X is greater than -2 and less than 2.
No. Is that possible?
No, either.
It is not possible, yes? And is not correct. Yes, you have to write or. Yes? So this means that if x squared is greater than 4, then either x is less than -2 or x is greater than 2. Actually, these two statements are equivalent now. Is that clear? Okay, now can you tell me now how to solve that? That's the same story, but instead of having 4, which was a friendly number, I have 1/3. So what should I write the answer? So this means that, what is the answer? X is greater than 1 over square root of 3, but there is another possibility, which is less than -1 over square root of 3. Okay? But remember, now you need to write the answer. I ask you on which interval or intervals this function s, which was written there, is actually strictly increasing. So what do you answer now? So I would say that if x is less than -1 over square root of 3, or x is greater than 1 over square root of 3, then s of x is strictly increasing. But to be honest, in principle, if you want to write it correctly, you have to put equality here. Because it doesn't matter if I pick a point, yes? That's the end of the interval, yes? It's also included. You cannot say that my function is increasing or decreasing at one single point, yes? So the function is strictly decreasing and increase on these two intervals. So it means that, I don't know, if we draw this with GeoGebra, if this is 1 over square root of 3, and if this is -1 over square root of 3, I know on the left-hand side of this and on the right-hand side of this, the function goes up. This is what we know for the time being. But how it goes up, we don't know. But we know that if I see this part of the graph, we can do it using GeoGebra later. The function is going up on this one. What does it mean? It means that it goes up. And it also goes up here. But if I ask you the question where the function is decreasing, how do you answer it now? Okay, where the same function, where the function is decreasing? So where? Yes?
You have to look for when the derivative is less than.
Yes, we have to understand where the derivative is negative. But this is not, you don't need to solve it all over again. Hopefully you can predict what will happen. Can you predict what will happen?
X squared will be less than 1.
Okay, so let me ask you this question again. So if I ask you x squared less than 4, and I ask you to solve this inequality, what is the answer you give me?
X is less than -2 or greater than 2.
No, you have to be careful about or and here.
Less than -2 or
No. Which numbers are the numbers so that when you square them are less than 4? So of course, one possibility is to write x less than 2 is not wrong. Of course, if x is less than 2, it is guaranteed that x squared is less than 4. But is this the whole story? Yes.
Well, x is less than 2 and greater than
minus 2. So you have to respect, because if I go much lower, for example, if I go to minus 10 is less than 2, but if I square minus 10, it suddenly becomes 100, and 100 is definitely not less than 4. So there is a limit how far I can go to the left, and what that limit is, the limit is it should be greater than minus 2. Yes, because if I go to the left of minus 2 even slightly, when I raise it to power 2, that becomes bigger than 4. So this is the meaning. So if x squared less than 4 means x is between minus 2 and 2. So these two are equivalent. Okay, so if I want to solve that one, then I would do the same thing, yes? Okay, what's the answer to this one now? X is less than 1 over square root of 3n. Is that the whole story? No, exactly like this. I have to stay here. So x should be between these two values. So the answer again is if, so I can say the function is strictly decreasing on the interval so x greater than or equal to minus. This you have to put equality if you want to be very careful. But if you write just strictly, I will accept it from you. It doesn't matter because it's a little bit more advanced if you want to talk about those things. Is that understandable? Yes?
By solving this, is it always better to solve for the decreasing one, or is it better to solve?
There's no difference. If they ask you specifically about increasing or decreasing, you answer accordingly. But usually, when you know all intervals for which the function is increasing, the rest is clearly are the parts that the function is decreasing. So that's why I'm saying, in principle, you didn't need to solve that problem. Yes, because here, this is the real line. This is minus 1 over square root of 3, and this is 1 over square root of 3. You realize this function is increasing only on two intervals, one to the left and one to the right. So what is left is those places the function is not that one. Yes?
But if the graph is straight
Mhm.
or horizontal, how would why would you call that? Is still increasing?
No, I understand your concern, but you don't need to be worried at the level of your course about those things, yes? Because in principle, I can say the function is still strictly increasing if the derivative is greater than or equal to 0. But the number of times that the derivative becomes 0 should be finitely many. Okay, so you shouldn't be worried about those. So for example, we don't know, you don't have this, this is the example comes to my mind, but you haven't studied how to differentiate this function. So this function is strictly increasing if you draw the graph. But if you take the derivative of this function, yes, the derivative of x is 1. In Math 4, you will learn that the derivative of sine is cosine x. But the derivative becomes 0 in a lot of points, but still the graph is strictly increasing. But we don't want to address these questions, yes? Yes?
I'm not sure if this goes into the same concern, but I'm a bit unsure how we were able to say that x is smaller than or equal to or greater than or equal to the bounds we found, or how we got from the smaller than or greater than from our inequality solution to the greater than or equal to and the greater than or smaller than or equal.
I can comment on that. I think it's understandable. And by the way, there are I think many confusions even in math literature. I don't know, but let me just try to describe this once for all because so let me just give you a concrete example. So here, this is 1. Yes. These are filled, these are in the domain. And this is 3. So when I say that the function is increasing, what is the interval that the function is increasing? It's strictly increasing. So do you write this? Or if I write this, that is also correct. Is the function, if I say that what is the largest interval on which this function is strictly increasing, do you write this one or that one? My claim is to write this one, not that one. So this is understandable. You might say why I can put equality. Yes. So for example, if the function after this point the function goes down, so still do you choose this one or that one? The second one. So did you answer your own question?
Or yeah, I guess then my follow-up question is why didn't we just prove that s prime of x is greater than or equal to 0?
That's what I'm saying. In more advanced texts, you will have this formula. So in your book, they have written that if f prime is greater than 0, the function is strictly increasing. This will give you this wrong impression that if f prime of x is greater than or equal to 0, then the function is increasing, not strictly increasing. But I'm telling you that this is not completely correct. Because the example that I mentioned here, f of x equals to x minus sine x, this is really strictly increasing, even though the derivative is sometimes 0. So this is beyond the scope of this math 3C lesson.
But it's not so simple that we, or if we did prove that f of x is greater than or strictly greater than 0, it could still be the case that it's just increasing and not strictly increasing.
No, the other way around. If f prime of x is greater than or equal to 0, still there is a chance that the function is strictly increasing.
Yeah, there's a chance, but it's not, you can't be sure.
Yeah, we cannot be sure.
It's not that simple.
No, but there are some additional assumptions that make it sure, okay, sometimes. For example, one case that is very easy to understand is that the number of times that the derivative becomes 0 is finite. Yes? Yeah, so in that case, still, so what I'm saying is that f prime of x greater than equal to 0 and f prime of x equals to 0 only for finitely many number of x's, then still you can conclude that the function is strictly increasing. But again, this is a counterexample. I mean, this is not a counterexample. I mean, this is a different scenario because this is the derivative of this is greater than or equal to 0, but it is equal to 0 at infinitely many points, but still the function is again strictly increasing. Yeah, I mean, that's it. But you don't need to be concerned about those very specific cases. Okay. So actually, this is essentially the lesson. So let us, by the way, check it on GeoGebra. That's probably a good idea at this point. Okay, so let us, for example, put that function here. So I just write y instead of s of x, and the function was x to the power of 3 minus x plus 1, yes? So you see, oh, I made a mistake. Minus x plus 1. So that's the function that you see here, yes? So if I probably take the intersection point, or I think Yeah, intersection point is good. So if I take this one with the x-axis, so that is the point. So minus 1 over 32, minus 1.32 is approximately minus 1 over square root of 3. Is that right or no? No. Oh, okay, so sorry, that is not the case. Yeah, I have to find these points. You see, that is not a good point. So you see that here, so the function, it is very clear, by the way, that the function increases here up to this point, yes? And then it start decreasing from here to here, and then it start increasing up to here. So that is exactly what we realized. Yes, we realized that the function is increasing on two intervals, on the left and the right, and it is decreasing on the interval in between. But the point is that what the numbers are, I think we will study this later. This is called maximum point of the graph, and this is called the minimum point of the graph. Yes. So let us, I think there are some features on GeoGebra that you can do these. So it's extreme values. Yes, let us just do that for this graph. This will give you these points. And this 0.58 is 1 over square root of 3, and minus 0.58 is actually. So it means that before this point, the graph is increasing. After that point, the graph is increasing, but between these 2 points, the graph is decreasing. So that is by calculation. So the whole point of this lesson, actually the reason that GeoGebra knows how to draw the graph, or at least we know that there is nothing interesting happening in later. By the way, even if you draw it with GeoGebra, I want you to understand there is no guarantee that this graph will not return back. How do you know that this is the whole story of the graph of this function? Because your display is limited. You haven't seen other parts. For example, how should I know that if I go higher and higher, I will not have surprises? In other words, how do you know that? So the function is like this. This display is limited. How do you know that it goes higher and higher and suddenly returns back here? Yes? This is possible because you don't see the whole picture, you just see one part of the graph. But do you think that this will happen? This is the power of mathematics. I want you to understand. Even if you have GeoGebra in the exam, there is no guarantee that there are no surprises there for you. Because I see the graph like this, but I want you to understand, even with GeoGebra, there is no guarantee that this will not happen. The monitor is limited and shows this part to you. Yes? How do you know that such a thing does not happen? I want you to understand that this is only done with rigorous mathematics. Even computers are not good. So of course you can start moving things around and see what happens, but you have limited access whenever you have a finite. This will not happen, definitely, yes?
But if you choose to extreme points,
Yes.
doesn't it guarantee that if they calculate it for the whole graph versus still
No, because I mean, yes, they don't. I don't know about that, how they have written down, but it might happen that there is some extreme points there. If I move to the right, then GeoGebra shows the other extreme points.
You get the last points on.
Yeah, of course you are right here in that case. Yes, but that is important, yes? So, I mean, forget about this. How do you know that this is not happening for this graph? Based on the calculation that you see on the board. Yes?
In this case, we prove that the k value will always be positive on these.
No, make it very simple.
We know the k value.
Why this does not happen? Yes?
For that to happen, the graph for the function would have to be increasing outside the bounds that we proved.
Yeah, exactly. Exactly, that's the answer. Because we showed that the function is increasing on two intervals. Yes? We've proved that before this the function is increasing, and we also showed that after this the function is increasing. But if this is going to happen, this is in contradiction with what we have seen. Because if this is going to happen, it means this is not the case that the function is increasing on the right hand side of this number, because at this point it will go down again. But we proved that this is not possible, because we showed that here is minus 1 over square root of 3, here is 1 over square root of 3. We guaranteed that on the left hand side and the right hand side, the function increases all the time. Yes? And we also showed that in the middle, the function decreases all the time. And there is no other possibilities, yes? So this cannot happen exactly because of this. I want you to understand, because that's a deep thing to understand. Do you understand the connection between these two? Yes? So definitely this is not going to happen. So when you see the graph on GeoGebra like this, you don't expect any kind of surprises on far to the right or far to the left. This is more or less the whole story. Okay? So that is the important thing. So in this chapter, we'll learn how to qualitatively draw precise graphs. Not exactly, because of course computers are better than us in locating all these points precisely. But qualitatively, we should be able to draw this graph. And we should be able to guarantee that there are no other interesting points for this graph to look for. Yes? This is already guaranteed here, that this will not happen. I want you to understand. Yes? Is that clear or not? Because this is important to understand at this point. Okay. Any questions? Yes?
Can you choose that GeoGebra provides exact values instead of approximations?
I don't know about that. I don't think it is possible here to do it. Yes? Because the precise values are coming in the CAS view. And I don't think, yeah, you can ask GeoGebra to solve that exactly. But if you want to combine this with the graphical tool, I don't know any way to do it. Yeah. Any questions? Is that clear? Okay, so there's also a good question in the book. So here in this problem, f prime of x is equal to 0, then because this is the graph of f prime, so you should tell me these points, yes? Of course, you can read them. For example, this is minus 1, minus 2, minus 3, minus 4, minus 5, and then you can just read those things. It's understandable, yes? Now, let us answer part B. On which intervals the function is strictly increasing? Not this function, not this graph. Of course, this graph is easy. Here, this graph is increasing. Here, this graph is decreasing. Here, this graph is increasing. Here, this graph is decreasing. But this graph is the graph of f prime, not f. This question is regarding f. So you need to understand how to read the information here to get something about the original function f. Okay, now can you answer on which interval the original function f, which we don't have access to, is increasing? Yes?
The derivative is positive
It so means where?
between minus 5 and minus 1.
Yes, that is one part. Do you understand? Because from minus 5 to minus 1, this is the graph of f prime. And because this part lies above the x-axis, it means the function f prime is positive on this interval. If f prime is positive, it means the original function f is increasing. So I hope that you are not confused. This part of the function is both increasing, this part of this graph is increasing and decreasing simultaneously. But I hope that you are not confused, because on all these parts, every part here you see lies above the x-axis. And it means that this function is positive on this interval. But this function is f prime. So f prime is positive means the function is increasing. So on this interval between minus 5 and minus 1, the original function is increasing. Again, between 3 4, 5, 6, 7, between 3 and 7, still the function is increasing, the original function. Yes? Okay, now, but here, it's below the x-axis, so the function is decreasing because f prime is negative. What about here? Here, again, the function is below the x-axis. The graph is below the x-axis. It means this function is negative. When this function is negative, it means the original function is decreasing. And again here, this is below the x-axis, so this function is negative. Again, the function is decreasing. So is that clear? So these are very good questions. You will see them in the future as well. So the graph of the derivative is given to you, and you are supposed to understand something about the original function. So is that understandable? Okay. Any questions? Yes, I will just update the Google Classroom. We have enough time. And then, by the way, we have to also decide about the data for the exam. So let me just pause recording here now.